For the cumulative practice problems or extra problems, we have problem number 1. It says a tetrahedron is a triangular pyramid with 4 equilateral faces. Han has a box of tetrahedrons with each of the 4 vertices marked with one of the numbers 1, 2, 3, and 4. He rolls one tetrahedron and makes note of the number on the vertex that points up. After rolling these tetrahedron 10 times, he notices that the number 1 appears 5 times. Han suspects that this tetrahedron is weighed in some way to make 1 appear more often than the other numbers. Using another tetrahedron from the box that he has confirmed is fair, meaning that all the numbers tend to be rolled with equal frequency. Explain a process Han could use to gather evidence to show whether this tetrahedron is also fair. So think about it, right? And this is the shape of a tetrahedron, in case you didn't know. What would you do? I mean, think of a way that it's a more reasonable way. I mean, if you are given something and they're telling you that they're rolling it and then it's showing a certain amount of numbers every time, more often than others, then my first instinct would be to do it myself, right? Like, I want to try it. But I want to try it with something in mind. And that will be to pay close attention to the number 1, right? So I want to make sure that I pay close attention to that. So I would just roll the figure, and if I see that the number 1 appears around 5 times, then I can, or more, or even more, I can discard that the tetrahedron is unfair. But if it's not showing at least an average, maybe around 4 or 5 times, maybe it's just showing once, then I might raise an eyebrow, right, as to maybe what they're using it's somehow altered. So that's really what it is, right? And it tells you here basically that, right? It tells you to repeat the process and to see if the number of times 1 should be rolled and see if 5 is unusual or not. So like I said, you want to compare what you get with whatever they say they have. In this case, it says that 5 times is the number 1 appear 5 times. So if it does, then you can just say that it's fair. All right, next one, it says a spinner is divided into 3 equal sections, label A, B, and C. Based on probability, how many times would you expect the spinner to land on C after spinning it 30 times? Explain your reasoning. Okay, so if I have 3 things and I am spinning it 30 times, how many times does each of them get to be spun? Just think about that. 30 times, and then I have 3 equal sections. So if you say 10, then that's right. Yeah. How many times would you expect the spinner to land on the C spinner after spinning it 3 times? So 10 times will be this probability. But if you think about how much is that in a proportion, that will be 10 out of 30, right? And that will be 1/3. So about, it should land, right, like about 1/3 of the times spun, or 10 times. So based on that, and I want you to think further, what is 1/3, right? 1/3 is 0.33. So you can use that information to answer the other 2 questions. So it says, after spinning the spinner 30 times, the frequency of the outcome is 9 times for A B 8 times, C 13 times. And the question is the number of times the spinner landed on C reasonable based on your expectation? Explain your reasoning. So we have 1/3 or 10 times, and they're giving us numbers that are pretty close to that, with the exception of C, which is in this case 13 times. So that will be 3 times more than what we found at the beginning. But I mean, it's pretty close to 10, the other two. And I mean, 13, give it or take, is close. It might depend on other things, but I'll say that, yeah, it's reasonable. I mean, they're pretty close to 10. So that's that. So for C, it says the spinner is spun 3,000 times. Give an example of a number of spins that result in C that will be possible but unusual. Explain your reasoning. So if you tell me a very high number, very close to 3,000, I'll say that that's not possible. Just because all these rules of probability and all that, I mean, something is wrong if you're spinning these and you're getting very close to 3 times. You're very close to that, right? To 3,000. Maybe if you tell me between 1/3 and, I don't know, maybe a little bit more than 1/3 of that will make sense, right? Like 1,000 times or around there. I think that would be a pretty reasonable number. So, you know, this is very extreme in going very close to something that doesn't make sense to something that makes sense, right? You cannot tell me one time if you spin it will be close to 1/3 of that. So 1,000 around there is reasonable. But if you tell me 10 times, right, that's very unreasonable. The same thing if you tell me 2,800, that's very unreasonable as well. That's almost 100%. And if you think about 1/3 is 33%. So a number that makes sense around there will be 1,000, maybe a little less, a little more than that. And that's what they tell you here. Last problem says, based on classical genetics, 2 heterozygous parents should pass on the recessive trait to their children 1/4 of the time. So think about that as a percent. What is 1/4 of anything? Okay. What is 1/4 out of $1? A researcher puts 20 fruit flies that are heterozygous in a container, then examines the children. 46 of the 100 children have the recessive trait. Is there a reason to believe something is wrong with this experiment? Okay. So you need 2 things here. And they throw all these numbers at you, and some of them, I mean, all the numbers are important, but you just need to take into consideration some numbers. For example, the fact that they tell you how many flies they're putting in the container, that's just telling you, okay, we gather a sample of 100 people. And that's that. But what continues is what matters. It says that they're going to examine their children. So now you have that 100 children were selected out of those 20 fruit flies. And I don't know if children is the best way to name these, but whatever they say. So they're children. So 46 out of 100, how much is that? That's almost 50%. So they're saying that almost 50% of the children have the recessive trait. But that's not what genetics says. It says that it's actually 1/4 of that. Okay, 1/4 of the time that happens. So how much is that? That's 25%. So is there a reason to believe something is wrong with this experiment? Yes, because 46% is almost twice as much for what this classical genetics definition or theorem, whatever that is, says. So I would definitely raise an eyebrow and say something's wrong here, because that doesn't make sense with what we know already about genetics. So this is really the core of this lesson, just to think about the probability and just using what you're given to prove or disprove a claim.